Hello everyone, my name is Ardel Dominic Lexi Beaver from BSAEE 3-1. So for this video, I will be answering some questions regarding why is it necessary to have a standard altitude, the different types of altitudes, is it possible to that the geopotential and geometric altitude is equal, and describe the relationship of the properties of air whenever the altitude change. And we will, in this video, we will also derive and interpret the hydrostatic equation and give some examples for the overall. So first, why is it necessary to set the standard altitude? It is necessary for us to set standard altitude because in the field itself, if gagawa ng aircraft, the effects in different altitude varies depending on the parameters, depending on the density, depending on the pressure, depending on the temperature. If gagawa tayo ng aircraft, ayun yung mga makaka-apekto ng performance niya. So for us to have a common grounds and on identifying the aircraft performance, standard atmosphere and standard altitude is created so that we could have a common reference and we can compare whether the performance of the aircraft in the standard sea level is greater or good compared to compared to the altitude above the sea level. So it is very necessary and vital for us to understand this standard altitude. For the next question, the different types of the altitude. So basically, we have 6 types of altitude. That includes the geometric altitude, the geopotential altitude, and the absolute altitude. For the geometric altitude, it is the actual altitude from the sea level or from the ground. So let's say, for example, you are standing in the second floor and measure nun is 5 feet. So you are standing 5 feet from the ground. So next is the absolute altitude, which means that the absolute or the altitude measured from the center of the earth. So radius of the earth plus nung height mo dun sa ground. So kagaya nga sinabi ko, 5 feet. Para makuha natin yung absolute altitude natin, i-add natin yung mismong radius ng center of the earth para makuha natin yung absolute altitude natin. Next is the geopotential altitude, which have a or not have. It is the fictitious altitude in which we assume that there is no change or we have a constant gravitational acceleration, which in this case 9.8066 and 32.174 feet per second squared. Now it is also called as the gravity adjusted altitude. For the other types of the altitude, we have the pressure altitude, density altitude, and temperature altitude, which correspond to or associated with ambient. In pressure altitude, it is associated with ambient or actual pressure. Density altitude associated with actual density of the air in that particular altitude. And temperature altitude also corresponds to actual or ambient temperature na nararamdaman nila in that specific altitude. So, for the next question, is it possible to that the geopotential altitude is equal or same in terms of value with geometric altitudes? Possible. My answer is half-half. Of course, sa standard sea level, they are not they are equal dahil isa lang yung constant when it comes to geopotential altitude and geometric altitude. But as we progress our altitude, dun na magkakaroon ng differences. So, somehow at sea level, equal sila, but as the altitude progress or altitude increases, nagkakaroon na siya ng nagva-vary na yung values nila, especially the geopotential altitude is affected by the gravity itself. Kaya nga lahat ng given natin is geopotential altitude yung ginagamit natin, lahat ng problem natin. Not all, but mostly. So, describe the relationship of the properties of air whenever the altitude change. So, for this one, I created a table or representation on how the air properties of air, which is the density, the temperature, and the pressure changes whenever the altitude changes. So for this one, we can see that the altitude is nasa ground tayo. So ang pressure niyan is 101,325, density 1.225, temperature is 288.16. But kapag umangat tayo, it is feet, not meter. So kapag umangat tayo sa 200 feet, 250 feet, pressure is 98355.344, density is 1.196, and temperature is 286.535. So relationship of altitude and pressure. So ayan, ang relationship ng altitude and pressure, the nearer we are in the sea level, and the greater the potential to have a greater atmospheric pressure because we are greater air molecules around us. So, mas mataas yung pressure natin sa ground kesa tumataas. So, habang umaangat yung altitude natin, mas bumababa yung pressure natin. That's the relationship. So, sa density naman, this is because when the altitude is in the sea level, the air molecules are almost compact, thus greater it become denser. But when the altitude increases, the air molecules will be separated from each other, thus becoming less dense. Kaya ang density natin sa kapag tumataas yung altitude natin is bumababa rin kasi umuonte yung molecules natin, so nagiging less dense sila. For the temperature naman, we all know na the more na lumalapit tayo, syempre sa ating atmosphere, mas lumalamig. So, kagaya sa Mount Everest, kapag nandun ka na sa taas, masyado na malamig doon, and such. So, the relationship between all these three is when the altitude increases, the pressure decreases, the density decreases, and the temperature also decreases. So, for the derivation and interpretation of hydrostatic equation, I provided a separate video, and also I input the examples on that video. So, ayun.
So for in this video, we will talk about, or I will explain how we derive how we derive hydrostatic equation and the interpretation of it. So in hydrostatic equation, para mas mabilis natin siyang maintindihan, gumawa ako ng cube, isolated cube. So para mas mabilis natin siyang magets, ito muna yung sample natin. So each side of the cube represents the unit measurements. So for this one, I will be using 1 unit for the length and 1 unit for the width. So we all know that the pressure is the normal force acting on the body. So ang normal pressure dito ay mag-a-act dito sa side na to. So may pressure tayo dyan. And this one is the height of our cube, or height of our um, subject. So we can represent this as change of height, or dH. We also have the pressure above this cube, so it is pointing to the cube. So it is the pressure plus the height, change in height. Pero hindi dapat natin kalimutan yung mismong weight ng cube. So ang weight ng cube is the pressure times area and the height, so dH. Take note that all the forces na upwards, so upward forces is positive, and all the forces na nakaturo sa baba is negative. So ito, we can say na itong force na to is negative, and this force is positive, and this force is negative. So for the bottom equation, we have the before that we all know that the equation of the pressure is P over F over A. And so kapag i-isolate natin yung force, magiging force is equal to pressure times area. So for the i-divide natin siya sa tatlo para mas mabilis nating makita kung paano natin siya na-isolate. So for the bottom surface, we have P, which is ito. So magiging F is equal to negative P. So hindi pala siya negative. So positive P siya. So pressure times area. So for the bottom surface, ang force natin dyan is P times 1, which is yung area na 1 times 1. So, ayan yung makukuha natin sa bottom surface. So, ayan. For the upper surface, we will also use F is equal to PA. And since negative yung pressure doon, dahil itong direction niya is negative, F is equal to negative P plus dP. So ito yung magiging pressure niya, di ba? Ito yung pressure niya. So yung area natin is 1 times 1. So area is 1 times 1. So ang makukuha nating force dito is F is equal to negative P plus dP. Sorry, hindi pala nakikita. So, ayan. Negative P plus dP. So, ito yung makukuha nating force sa pangalawa. Next is yung sa weight natin. So, weight. So, that includes this part of the equation. So, for the weight, we all know that F is equal to M over A. Pero we also know that the formula of our mass is also gives us density over or times volume. Saan nanggaling to? We all know that mass is density. Yan, density is equal to mass over volume. So kapag in-isolate natin si mass, makukuha natin si density times volume. So therefore, F is equal to mass, which is or the density of negative rho times 1 times the height, which is dH, etong part na to, dH, multiplied by the gravity. So, when we multiply it to the gravity, ito na yun eh. Ito na yung part na yun. So, yung force natin na makukuha dito is equal to negative rho gravity, and change of height. ito, change of height. So, i-box lang natin siya. And since we all know that kailangan nasa state of equilibrium tayo, so we need to sum all the forces. So, ang meaning natin ng equilibrium is all the forces must be equal to 0. So, meron tayong force 3, meron tayong force 1, meron tayong force 2. So, it is summation of 0. All the forces must be summated to 0. So, first one is ito, which is P times 1 plus 1 minus, since negative yon, P plus dP. Tapos minus ulit, rho g dH is equal to 0. So, having that, we will have, in-isolate natin siya lahat, P minus P plus dP is equal to rho g dH. So, saan nanggaling yung equals to rho g dH? I-transpose lang natin yung sa kabila para mag-positive. And so, i-ano natin yung factor out natin siya, magiging P or multiply P minus P dP, or pagsasamahin pala, so dP is equal to rho g dH. Cancel this and we will left with dP is equal rho g dH. So, yung negative mapunta dito, dP is equal to negative rho g dH. So, that is our hydrostatic equation. So, let us have a example. So, example number 1 is find the temperature, pressure, and density at 14 kilometers. So, alam natin na ang gradient region is between 0 to 11 kilometers and wala siya doon. So, papasok tayo sa isothermal region, which is hanggang 11 to 25, T is equal to C dahil constant. So, having that, kukunin natin yung mismong temperature sa 11 kilometers, pressure sa 11 kilometers, and density sa 11 kilometers. So, para makuha natin yon, we will use the formula T is equal to TO plus AH. So, T11 is equal to 288.16 Kelvin plus negative 6.5 Kelvin per kilometer times 11 kilometer. So, cancel the kilometer and i-compute natin is T11 is equal to 216.66 Kelvin. So, ayan yung value ng temperature natin at 11 kilometers. Ngayon, solve naman natin is yung pressure sa 11 kilometers, which is ang ating formula ay P is equal to PO times T11 TO 5.26. So, PO is yung SSLC natin. So, P11 is equal to SSLC, which is 101.325 multiplied by the temperature. Itong nakuha natin, temperature is 216.66 Kelvin. And yung SSLC natin sa 0, which is 288.16 Kelvin, is to 5.26. So, cancel the Kelvin. Ang matitira is yung Pascal dito. Pressure natin at 11 kilometers ay 22,606.82333 Pascal. So, as you can see, bumaba yung pressure kapag umaangat. So, it is part of the relationship of the of the pressure and altitude. So, next is the density. Density at 11 is equal to density at SSLC multiplied by temperature at 11 and temperature as SSLC raised to 4.26. So to get that, V11 is equal to 1.225 kilogram meter cube multiplied by 216.66 uh, Kelvin over 288.16 Kelvin as the SSLC raised to 4.26. So hindi na ako magdidig deeper kung paano naging 4.26 yan, pero it all boils down sa sa hydrostatic equation natin. So our density in 11 kilometers is 0.36350 kilogram meter cube. So, i-square na natin siya lahat. So, sa isothermal region natin, so alam natin na si 14 kilometers ay pasok sa isothermal region. So, in isothermal, temperature at 11 kilometers is equal to the temperature of 25 kilometers. So, nasan ba tayo? 14. So, pasok. So, temperature at 14 kilometers is equal to 216.66 Kelvin. Ngayon, ang formula natin for the pressure is pressure at 14 is equal to P11 multiplied by natural logarithmic of E negative G RT, and then yung change ng height. Ayan. So, nakuha na natin si P11. So, makuha natin si 14. So, si P11 natin, which is ito. Ito pala. So, 22606.8233 multiplied by logarithmic function of E 9.866 over 2.87.08 times the temperature, which is 287.08, and change of temperature is 14. Kailangan natin siyang gawing meter. 14,000 minus 11,000. So, P14 is equal to 14,087.83. Ngayon, ganito rin naman yung formula for the density. So, density at 14 is density at 11 multiplied by E, G, RT. Pero kailangan syempre, mapapalitan natin yung density kasi yun yung hinahanap niya. So, sa density 14 is equal to, ito naman gagamitin natin, itong part na to, 0.363508 multiplied by E negative 9.866 to 287.08 multiplied by the temperature SSLC 827.08 216.66 pala, 216.66 times ito lalagay na rin natin dito is 11,000. So pwede naman natin idiretso na ng 3,000, pero para hindi malito, ganyan na lang gawin. Rho 11 is equal to 0.226476388 kilogram meter cube. So, at 14 kilometers, ang density natin is 0.0226. Ang pressure natin is Pascal, 14,087.83 Pascal, and the temperature natin is 216.66 Kelvin. Sa ating next example number 2, we are tasked to find the pressure, temperature, density, altitude. So, temperature, pressure, density, altitudes at 4.72 times 10 raised to 4 Pascal. Ito yung ano natin, ito yung pressure natin at a specific altitude, and temperature at specific altitude of 255.7 Kelvin. So we all know that itong dalawang to is nasa gradient region. Bakit? Kasi alam natin na um, below the 11,000 is meron pa tayong 11,000 meters, meron pa tayong 22606.8233 Pascal. So dapat yung pressure, kung mas mataas yung pressure kaysa sa kanya, ibig sabihin nasa baba niya yung altitude. So it is between 0 to 11 kilometers. Pero kapag mas mababa na sa kanya, sa 22,606, 606, possible na nasa isothermal region na. So, gagamit tayo ngayon ng relationship para makuha natin ito, gagamit tayo ng relationship ng pressure, which is P. So, ito kukunin natin muna is for pressure. So, PPO is equal to 1 plus AHTO. Ito yung nasa formula natin. So, 5.26. So, bakit ito yung ginamit natin, hindi T final over TO? Para mapalabas natin yung mismong height niya. So, for this one, at a specific point, ang value natin dyan is 4.72 times 10 raised to 4 Pascal over yung SSLC natin, which is 101,325 Pascal, is equal to 1 plus lapse rate of 0.0065. So meters ang gagamitin natin. Bakit? Kasi yung unit natin sa Pascal is naka Newton per meter squared. So it is only right for us to use the meter. So Kelvin per meter times the height, which is ayun yung unknown natin, hindi natin alam yan, ayun yung altitude na hinahanap natin, over the SSLC of temperature is 288.16 raised to 5.26. So, meron na tayong ng height. May option tayo kung sa calcul natin, pwede natin siyang i-shift solve. Pero kapag pinagpalit-palit natin siya in algebraic way, magiging ang equation niya ay 4.72 times 10 raised to 4 over 101,325 raised to 1 over 5.26 na lipat minus 1 times 288.16 over negative 0.0065. So our height is 5992.907235 meters. So sabi dito, at 5,992 meters naramdaman niya ang pressure na 4.72 times 10 raised to 4 Pascal. So same thing goes with the temperature. For the temperature, para mahanap natin yung temperature, we will use the formula TO plus AH. So nakalabas din si AH. So eto, hindi na natin siya gagawing HF minus HO dahil alam natin na si H is itong hinahanap natin is unknown. So hindi natin alam kung ito 0, ito blank, di ba? So ito is HF na siya. So TO, which is given na siya, ito 255.7 Kelvin is equal to SSLC, which is 288.16 plus lapse rate na 0.0065 multiplied by the unknown height. So we can find the height, which is equal to 4993.846154 meter. So at approximately 5 kilometers is nakaramdam siya ng 255.7 Kelvin. So finally, for the density, since wala tayong given na density, hahanapin pa natin kung ano yung density niya at this specific point. So, using that, we will be using the ideal law or yung P rho RT, ideal state, or nakalimutan ko yung tawag, basta yung rho RT, P rho RT. So, at specific point, zero daw is equal to the pressure RT, which is equal to 4.72 times 10 raised to 4 Pascal over 287.08 times 255.7. So, calcu, we will be having 0.642996091.5 kilogram per meter cube. So, hindi pa ito yung final answer natin. Store value natin siya para makuha natin yung mismong value niya. So, again, gagamitin natin na formula is isothermal region, rho, which is ito yung hinahanap natin, or ayan yung at specific in continuation, density at specific height is over density at SSLC is equal to 1 plus AH over PO raised to 4.26. So hindi ko na ulit kung bakit naging 4.26 yan. So substituting all the values, so itong density natin is A, which is itong store value natin, over 1.225 is equal to 1 plus lapse rate na negative 0.0065 times height over 288.16 na temperature, SSLC temperature raised to 4.26, and we will have a height of 6224.883174 meters. So as we can conclude, there are different types or different altitude airplane could have. So iisa lang din yung mga nararamdaman niya, pero the airplane can travel at this specific altitude, which is approximately 6 kilometers, approximately 5 kilometers ito, and lastly approximately 6.2 kilometers. So that would be all for the example 2.